This video is going to be focusing on the wave speed equation. V equals F times lambda. And specifically, we're going to be focusing on the three variables. We got wave speed is V, frequency is F, and lambda, the Greek letter lambda, is for wavelength. As usual, when we're working with these variables, you also have to know the units for each of these variables. Velocity is going to be meters per second usually, wavelength is going to be in meters usually, and frequency is in cycles per second, which is also called hertz. And you're going to need to know all of these. Now luckily you do have some help. If you remember, you have the equation sheet at the front of your notebook, which you get to use this yellow equation sheet on all of your quizzes and tests. When we look at this equation sheet, we can see the equation is right here, so you don't have to memorize the equation. And then looking over here, you can see all of your variables, frequency, wave speed, and wavelength. So you don't have to memorize the variables themselves. But what you do have to know are the units, because nowhere on this yellow paper are the actual units. And that's the thing we're going to focus on right now, the units. Right now I have basically three types of students listening to this video. I have some students who are looking at this and they're saying this is just too much to deal with and I'm not even going to try. So I'm just going to not even worry about the units. I'm just going to take the quiz and see what happens. Well, those kind of students, you might be getting a 0 or a 1 on your formative assessment. Then I have some students right now who are looking at these letters and they're thinking, man, I'll just memorize them right before the quiz and just try to remember that V is M over S and this funny symbol is an M and then frequency is hertz or cycles per second. Just memorize that and take the quiz and you might luck out and you might get a 3 or a 4 on the formative assessment. But guess what? We're going to see these again and another formative assessment and on your summative assessment and on your final. So you're going to be seeing these for the next few months. So really what you want to do is you want to know what these definitions are of these words. Definitions will help you with the units, and that's what we're going to focus on with the rest of this video. We're going to talk about wavelength, which is lambda, amplitude, which is A, which is similar to wavelength, velocity or speed of the wave, which is V, and then frequency, which is F. And then the units are going to come out like this. First, let's just talk about wavelength and amplitude. Because they're very similar, they're both measured in meters with a meter stick or distance, but they're measuring distance in two different directions for our waves. So here's sort of the quick version. You can see this picture here, here's a wave, and then here's wavelengths and amplitudes. But you need to know kind of more specifically. So first, let's talk about amplitude. Amplitude is going to be measured from the rest position, which is this dashed line here, which is the sort of the center of the wave, upwards to the top of the wave, like this, to the crest. It's called rest to crest. That's one way of thinking of it. There's various places you can picture this. It could be here, or here, or here. It's still from the rest to crest, but you can also get it from the rest position down to the trough. Rest position down to the trough. All right, and notice how all these purple arrows I'm drawing are the same length, the same number of meters, because this is the amplitude of this wave from the rest up or rest down. Amplitude. Now the wavelength is the other way. It's the length of a single wave. One way to kind of easily find it is just to go from one crest to the other crest like that, crest to crest. That's the easy way to draw it, but the easy way to remember what it is to think about a single wave looks like. So here's a single wave. Remember, a single wave is going to go down like this. It has a trough and a crest like that. That is one cycle. This blue wave is one cycle. And what I want you to notice is when I move the wavelength over here, you will see that this wavelength is the length from here to there of one cycle. Okay, you can put the wavelength for one cycle like that. That's how long the wave is. Or you can draw it from crest to crest. It's the same length. Or you can even draw it down here from trough to trough. Like this. You know, in all those cases, it's the same length. The length of one cycle. Wavelength. So here they are together. The wavelength is the length of one wave this way, and the amplitude is how tall the wave is from the rest position upwards. Now let's talk about velocity and frequency. I put these together because the units are kind of similar, and that's why students get confused between them. So velocity or speed is meters per second. We've been talking about that for a while. But then we have frequency. Frequency is cycles per second, which also equals a hertz. Right? 1 hertz equals 1 cycle per second. So the reason students get confused is because both of these look like fractions, and then they get them mixed up. So let's compare them and see how they're similar and different at the same time. So velocity is like a guy on a bike riding forward, right, in meters per second. He can move forward at 8 meters per second of speed. But also at the same time, there's another sort of speed going on. That is his pedaling, or actually the speed of the wheels rotating in cycles, right? This is why it's called a bicycle, because it's got 2 cycles on it, a wheel in the front and a wheel in the back. But as this spins like this, it can spin at different speeds. Right now I say 2 cycles per second. That would be like in 1 second, the tire goes around 2 times in 1 second. That's how fast the tire is spinning, cycles per second. That's called frequency, okay? So we got 2 sort of speeds going on here. Speed is how fast something moves forward in meters per second. And frequency is how fast something cycles or spins or oscillates in cycles per second. Frequency is sort of like fast. Frequency, fast, frequency, fast, frequency, fast, like speed. But instead of moving forward, it's how fast something cycles. So it's got similar units, cycles per second. When you compare them, meters per second is measured with a meter stick. That's how fast something moves forward. Cycles per second would be measured by, you would count the cycles, the number of spins, and measure the time. So cycles per second. So velocity, speed would be V, and frequency would be F. Something else I got to point out, and that is there's a bunch of turbine generators all around the United States making electricity for the outlets, and they spin at about 60 cycles per second. 60 cycles per second is how fast they're spinning, which is really fast. But that frequency is the frequency of electricity in all of our homes and buildings in the United States. So I wanted you to think about this. All electricity going to our electrical outlets at 60 cycles per second. What happens when you stick your finger in a socket? Bzzzt. You get zapped. Right? You get zapped and it hurts. Frequency hurts. This is our memorization aid for you. Frequency hurts or hurts or hurts. So I need you to know that frequency is also called hertz. Frequency, fast. Cycles per second, hertz. Frequency is cycles per second or hertz. Frequency is how fast something cycles. And 1 hertz equals 1 cycle per second. So let's use some examples with actual waves. First, let's talk about wavelength. Lambda length is in meters. So here are some waves traveling, and the length is going to be the distance between these crests right here. And this would be like a medium length, and as I change this, you can see what happens to the lengths as I change the frequency. The lengths, the waves get closer and closer together, so they have a posit. You can see it's a smaller wavelength. So going back to here, you can see, remember that the wavelength is the distance from crest to crest, like that. So just figure how long is this purple arrow? How long is it from crest to crest? And reading our waves starts here at 0 and goes over to 2.5. 2.5 centimeters, that's the length of that wave. So now you try this one. How long do you think this wave looks right here? Wavelength for this one. And remember, it goes from crest to crest. How long does that look? It's about 1.5 centimeters. Now let's talk about amplitude. So we'll come back to these 2 pictures of amplitude, but they are measured in meters. So here's our wave, and you can look at the amplitude. Amplitude is going to be how tall the wave is, a medium amplitude, and then I can increase the amplitude like this and make the waves like that. You notice how now this is going up and down farther, up and down further. It makes more amplitude. They're taller waves. You can measure from here up. There's a tiny amplitude. It's barely moving up and down. So these are tiny amplitudes. So over here, remember amplitude is the distance from rest to crest, like this. So how tall is this purple arrow from rest to crest? It looks like it's 0.24, 0.6, about 0.6 centimeters tall, or amplitude. Now look at this one. What do you think the amplitude is for this wave? So from rest position to the crest, like that. Now we're looking up here. And it looks like it's about 1.25 centimeters. Okay, velocity or wave speed. That's hard to show with a picture of standing still, but here, let's just show you different speeds. So here's like, you can see how fast these waves are moving this way. And that's sort of a medium speed. And then if I were to go like this, I'll slow down the speed like this. And now you can see this moving slower speed. Go back to medium speed, and I'm gonna go high speed now. Here are some high speed waves. Look how fast they're moving this way, meters per second or centimeters per second. And if I go back to my example, if I time this wave moving from 0 centimeters over to 5 centimeters, that distance is 5 centimeters, and the time, in this case, it took 1.31 seconds. So I go to my equation for speed. Velocity is distance over time, and that's distance is 5 centimeters, and the time was 1.31 seconds, and you divide it, and you end up with a speed of 3.8 centimeters per second. So that's an example of velocity or speed of waves. Okay, now frequency. Frequency is like speed, because speed is like centimeters per second, but this is like cycles per second, is the number of cycles that the wave's moving. So here's two different waves again. Let's go back to our example. So here is a frequency of 1.44 hertz. And then if I increase the frequency, watch what happens. Go faster and faster and faster and faster frequency. You can see that this goes up and down faster and faster and faster and faster. So the waves are going up and down quicker and quicker. Now I'll go back down to 1.8 hertz. Now I'll go down slower and slower frequency, slower frequency, slower and slower frequency. And this is 0.31 hertz. That means that this arm goes up and down 0.3 times per second. So it takes that's about 3 seconds to go up and down one time. I go super slow. So going back to here, you can see these are just examples of two waves moving different frequencies. This one was about 3 hertz, which is kind of a fast frequency, and then this one would be a slower frequency. So if this is 3 hertz, what do you think this one might be? This one's slower, so more like 1 hertz. All right, so let's do a few examples using part of our GESS, our GUESS method. We're just going to do the G and the U for these, the givens and the unknown. So here's the word problem. And you guys know how this works. You got to fill in the numbers in the green and the letters or variables with the purple. So let's see. Reading it. A sound wave moves 340 meters per second. So there's the units and the number through the air and has a frequency of 1200 hertz. And then the question is what? What is the wavelength? So those are what's in the word problem. So now we just got to put them down in our givens and our unknown. So the givens are the numbers. I got 340 meters per second and I have 1200 hertz. So those are going to be our givens. And then it says what, and that's going to be our question, the what part. So you just got to remember, you can use the yellow paper. So you know it's going to be a frequency, a wave speed, velocity, and then a wavelength, lambda. You just got to put them in the right spot. So this is, see how you have to memorize? You have to know the units. That's partially what you have to do to figure out where they go. First, this one's easier because it says frequency right there, frequency 1200 hertz. So that means this one's probably going to be the F for frequency. Let's do that one. That one's the easy one. And then it says, what is the wavelength? So wavelength is this funny symbol here. So draw that funny symbol because what's our question? And then this last one's going to be what we got. Already we got frequency and we got lambda. So this last one's probably going to be V, wave speed. So let's see if that makes sense, right? Speed, meters per second, that makes sense. So there you go. That's our givens and our unknown. Now we can go ahead and solve the problem. But we're not going to do that today. Instead, we're going to just, again, we're concentrating on the givens and the unknowns. So here's another problem. So let's see if you can do this one. How fast is a sound wave moving if 200 hertz sound creates 700 meter long waves? Okay, so you go through and mark these and then put them in the givens and then figure out which letters go where. Okay, so you see how the units are going to help. Looking here, I got 700 m, 700 meters. So that's probably going to be the length. The length is the only thing in there measured in meters. So length, wavelength. And then 200 hertz, frequency hertz, frequency hertz. So that's going to be frequency is in hertz. Okay, and the last one is wave speed. And it does say how fast is the question. So how fast is wave speed? That's our question. And there you go. Let's try one more. What frequency of sound would cause 15-meter long waves to move at 350 meters per second? So I'm going to transfer those down to the bottom. 15 meters, 350 meters per second, and unknown question mark. Again, going through my units, 15 meters, so that's going to be length, wavelength. And then we got meters per second. We've been doing that one for a while. Meters per second is going to be the speed, the wave speed, meters per second. And then the unknown, it says what frequency, it asks for the frequency, so you know that's going to be f. And there you go.